got a big foot here, pushing against that land. You try to push the land that way. Propels it forward. The car tire turning in this direction, the power supply to its axle, and it's trying to move or push that concrete or gravel or asphalt or dirt road again in that direction. Can't do that because the land is a heck of a lot bigger than the wheel, the apparatus which is attached to the wheel. The wheel and that which is attached to it is parallel in opposite directions, equal in opposite action. Water. We've got boats in here. We've got a little propeller sticking out here. And the water is, that propeller's turning at high velocity, or low, whatever it is. It's pushing the water in that direction. It can't push the water in that direction. It does, but it meets resistance, and therefore the boats propel in the opposite direction. You notice that the efficiency between the foot or the wheel is greater. Efficiency. This is the second efficiency. Then we come to air. That's a weird one. An airplane. That's an airplane. Color out here. Flowing against air. This is trying to pull the air in this direction, but creates a great enough force to propel the aircraft in the opposite direction. This is the third strongest in efficiency. So if we notice that we're gradually sucking air a little bit, we're losing our efficiency between the various mediums, as they are called in the scientific world. Mediums are land, 2, water, 3, air. We're taught that you must have a medium present in order to produce propulsion force. Well, in space, vacuum, almost gravity-free environment. Yet we can propel ourselves in that space. As one of the attendants here pointed out, he reiterated something that I have in written text. The reaction described has already been invented. It's called the ion motor. Great big tube, closed at one end, open at the other. In that is filled with a very highly explosive material with which it is impregnated with metal particles, fragments. Upon casting in free measured amount of water or oxygen, coming in contact with that highly explosive metal, it explodes violently. They usually do a cubic foot on each impulse explosion. I may stand corrected on the degree or measurement of thrust which is created, but I will have a go with it. This little cubic foot, as Dr. William S. Horvath explained to me, my home in Winnipeg, when he came to visit me last year, said that if you took a cubic foot of that material in the basement of my home. I have a pretty fair-sized 4-level split. And if we threw it, ignited it, like throwing water on it, exposing to oxygen, you may end up finding toothpick fragment material left in my home. That's how powerful this stuff is. Tremendous power. He said he took the cap off the end of that ion motor in my basement. It would probably go through my basement wall and travel underground for 3 to 4 miles before coming to an end. That's how powerful that thing is. Dr. Horvath is his name is Professor William S. Horvath, faculty of Oklahoma State University, Professor of Engineering. He's on loan to NASA as their aerospace educational specialist at Ames Air Base. He was on tour to every university in North America, in the place, giving lectures to students who were interested in aerospace work. When he came to my home, he looked at it and said, "Shit, damn boy, I'm impressed. I mean, this was a high-tech developed piece of equipment, I'd still be impressed. But what you've done with baling wire, plastic, a little bit of sewing machine motor, 1/15 horsepower, you're putting out about 8 ounces of thrust on each pulse. That's turning at 60 revolutions a minute. I don't believe it. I'm impressed." No. I question him on how many horsepower do you get out of that ion motor up there when you give it a 1? He says, horsepower? We don't measure that in horsepower. We don't even measure that in foot-pounds nor ounces. We measure it in decimal places of a watt. Now, the best of my recollection, the decimal places came up to 0.000476 of a watt. He said, "Hold your hand up." I held my hand up so that we could be illustration of how powerful it was. Takes his finger and he goes, "That was it, boy." He says, "One pulse in your machine are probably 200 times the force of the ion motor when it explodes 1 cubic foot of explosion in outer space." As you know, what happens inside internally, the explosion is equal in all directions around the outer rim. So it doesn't go anywhere that way. But the explosion, the impact itself is against the material, the explosive material itself, but it is nothing pushing against it. So that force which is pushed against the explosion material propels the machine in that direction. Now I have a question. What is that force pushing it? Where's the medium? Where's the water? Where's the fat? Where's the air? There isn't any. Now, it's all very well good to say you can cause a propulsion force by expelling mass, which we use to accept blindly. Where's the medium? So, what I'm going to show you is a device that I invented, if you excuse the expression, is pertaining to an out-of-balance wheel. I want to explain to you how the out-of-balance wheel works before I go into a film which I've tried to prepare to the best of my ability, which is homemade and will forgive me for my lack of editing skills, and you'll find quite a few mistakes in it, and motion picture production, but that's okay.
What hardware is being used to make one wheel? Let us look at a disc like this, and this will be a side section of that disc. Now through there is a hole. Attached over here is the hub of an axle. This supports the wheel frame itself. Through that axle is extended a shaft, which is attached to a control arm. On this side is a gear which is held rigidly by this axle. This is the gear, looking at the face of it. Now attached to the wheel are two like gears, same number of teeth. Now these gears are now fixed to the wheel on bearings, so that they are free to rotate, being meshed with, their teeth are meshed with the center gear. Now as this wheel makes one full revolution, this gear makes two revolutions. If we attach a crankshaft throw at that point, the center line of mesh, by the time this wheel makes 1/2 revolution, this planetary gear has made one full revolution, and its crankshaft throw ends up on the center line of mesh of the center gear and the bottom gear. So now we have the second crankshaft throw. As the wheel is making that one revolution, the crankshaft throw describes an inverted heart design, like so. Now, attached to that crankshaft throw is a planet, what I refer to as a planet. Actually, it's a pendulum-shaped mass, which is held by centripetal force in a straight line to the gear axle at all times. In other words, the centripetal force created by the rotation of the gear, turning at double the rate of revolution of the wheel itself, is sufficient to keep that planet extended like this, in a straight line to the axle of each gear continuously. In other words, the gear is here, the planet is here, pardon me, the planet is here, crankshaft throw is here, that center line is here. If the planet is over here, crankshaft throw here, that center line lines up, no matter where it is. It's always lined up with the center of mass at all times, because of centrifugal force and the rotation, the rate of rotation of that gear. In making one revolution, this planet, if we take the center of its mass as being right here, and being dead center over top of the axle, when it's in that location, it describes a different form of an orbit, different shape orbit. It comes around like this, back here, like that, a looping effect. Taking another piece of paper to explain that looping effect. Here's the wheel's axle. Now let's just deal with the orbit itself. That is the center of the map, the center line of the mass that it's following continuously in that orbit. As you can see, the mass itself is, through centrifugal force now in relationship to the wheel, is imposing a force in that direction upon the wheel's axle, which we could call a centripetal force, being imposed upon the axle in the direction of the planet. When the planet is over here, that centripetal force, going to pull away from the center of the axle, is imposed in that direction. When it's over here, its direction is straight down. So it's imposing a centripetal force in that direction. When it comes over here, it's imposing a force over here. So this is basically what's happening. You're having a force exerted in various places. Therefore, you'd have this, this would be the entire wheel, if it was in a zero gravity vacuum, a single wheel itself, would be going in every direction like this. Be oscillating around its center of mass, like this. With no stability, straight oscillation. When we tie two of these wheels together, one here and one here, to a common axle, or common plane to its axle, which I refer to as the line x-axis. This wheel is turned in this direction, but this wheel is turned in this direction. So we have this pattern setting up over here, identical but in mirror-like fashion. We now see that all of the original directions, which are 360 degrees around the circle, are now confined to four directions only. All of the forces which occur over here are imposed in that direction along the line XX. At the same moment in time, all the forces which were pulling the wheel in this direction are now imposed in one straight line this way. Now, meanwhile, while these forces here are pulling the wheel force forward in this direction for the force, the same thing is occurring in this wheel. Now those forces are transferred to the axle itself and imposed upon the line XX in that direction. When these forces alternate to the opposite side of that line XX, these forces created by these arcs impose an equal and opposite force in the opposite direction along the line YY, which is perpendicular to the line XX. I call the top Y positive direction, and I call this Y negative direction. We now find that we have a state of vibration, or a vibratory action is occurring upon the line XX because of these forces imposed in the direction of Y negative and the Y positive. The Y positive direction force are equal to and opposite the line Y negative force, so therefore we have a vibratory action occurring. When we stop the planet in what we call an electromagnetic trapping device, or electromagnetic trap, we stop the planet here at this point, and as it's coming around this way, we stop it at this point. Now that stopping of the planet at this particular position imposes a kinetic energy force at a 45-degree angle upon the wheel's axle, in this wheel and in this wheel. Half of this force, this kinetic force, is directed along the line XX, and it's neutralized by the equal and opposite force, 1/2 kinetic force directed along this line XX. So these two forces nullify any movement in that direction. But this 45-degree angle is bisecting a right angle. If we call this Y, and we call this Y in the positive direction, this is bisecting these two forces, this right angle, imposing 1/2 the force here and imposing the other half of the force, the kinetic force, in this direction. And the same is occurring over here. But you'll notice that we have two forces forward and one force back, and then two forces forward and one force back. As was depicted with the two-wheel module, the undesirable vibratory effect of the line XX along the direction of YY was still occurring, even though a resultant force in the positive direction along one direction of YY was being produced by a bias of the vibratory action. The undesirable vibration would be totally undesirable in a propulsion system. therefore, by employing a second module, this second module here, these two wheels, are tied together with the first module, but this module is 90 degrees out of phase, therefore eliminating all centripetal forces from creating any vibration of the line XX and nullifying or neutralizing all any motion along the line YY because of centripetal forces. See, all lateral forces in the direction along XX have been neutralized. Top module completes 90 degree of turn. The second lower module has made a 90 degree turn, but again, all forces in the direction of Y positive are neutralized by those forces applied along line YY in the Y negative direction by the upper module. Upon completing the next force imposing position, again, all forces have been neutralized along the line XX in either direction. Therefore, in this condition, or this arrangement, prohibits the movement of the line XX or the line YY, or either one in any one of the four directions. All vibration has been neutralized because the planet traps have not been energized. We'll now look at the module, the propulsion system, when the planet traps are energized, introducing the kinetic force in between the centripetally imposed forces. What you've just seen, you can now visualize two kinetic forces being imposed along the line YY in the Y positive direction with no opposing force in the negative direction. The two opposing forces are imposed along the line YY in the positive direction of Y positive by the upper module first, then the lower module, then the top module, then the bottom module, in one revolution of all four wheels. Therefore, the only propulsion force which is being imposed upon the line XX in the Y positive direction is that momentum force producing a kinetic force, the momentum of the mass itself of each of the planets, imposing its what I'm talking about is to examine the module itself and the action of the planet, as I explained before. You can see how the center gear, this one here, is turning this gear one full revolution for one half revolution of the wheel, and it locates the center of the mass of the planet directly over the axle itself, and it continues to do so as it completes the full revolution. Two revolutions of the gear have occurred. Now, to allow you to see an actual action shot of the planet in motion, we'll turn the wheel on. Now you can see how the planet is held outward by centrifugal force of the action of the gear and the gear turning on its gear axle. Now we will stop the planet from moving and crossing over the center line of the axle and introducing the kinetic force. Now we're going to introduce two wheels. When we back the camera up a little bit, you will see both wheels together. Now, what I've done is I've simply put a bolt to stop the axle, the planet from completing the arc over the center axle. And this is the action which occurs. You can see that the wheel wants to break up. It's only a plastic toy, but it does demonstrate the basic principle of which we're speaking of. Similar to what you saw on the television broadcasts. Now, it produces an unwanted vibratory action which would be destructive to the entire system. Now, how we circumvent that is by going into the details of the descriptive analysis of showing you how two modules are put together. We started off with one wheel. We've added two wheels together as the next step. The third step is to put four wheels together. Two modules are joined together.
120 centimeters.
Don't plug it in yet.
Don't plug it in yet, please.
Don't plug it. You have to go a little further.
Because what I want you to do is I want you to actually hold it in your hand and let it feel the force, okay? Because your brain is a very highly technical computer which hasn't been produced yet, mechanically. You'll see that the bottom has four. These are given to you by Bob Demet. They're pulleys out of an aircraft for control. They're just pieces of plastic. This thing here, I keep the center gear stabilized with, and I can reverse the center gear by simply undoing that from that.
You can plug it when you wish.
Okay? Now.
That should move down the table.
Well, you have to have it. No, it's not that strong. Okay, right now, it should move this way. Plug it in. I don't think we might get a little propulsion, but it's nothing dramatic. The best thing to do is put it in water or hold it. Well, you see what's happening. Would you please hold it here and here and hold it up in the air? Not up in the air. Just hold it like a pendulum like this. Just like that. Okay? With straight arms. Don't make a wire. That's your gear. Okay, now go over. Now your arms are pendulum. Bend right over. Bend right over. That's it. Okay. I'll just turn it slowly. You feel the force go backwards, then forward?
Yeah.
Which direction? What are you experiencing?
It's trying to go that way.
This way? Okay. Come on up here and somebody else hold it. Who else wants to try it?
It'll roll itself down the road here.
Well, we better go over there.
Outside?
Yeah. Does the force exist?
Yeah. I think you'd almost see it better just from running your blade up there.
Feeling. Oh. It might be a whack a bit.
Sounds like it's slipping.
No, it slipped to that. So all I have to do is take that off and hopefully that. I'm not too sure if that's right.
fluid too far. That's right. And in there. That's closer.
What do you sense? You want to try?
Who else wants to do it? You want to pull it? Okay, sure. You got to feel it to believe it.
Really? Have you ever convinced the patent department?
See it on water,
Bend right over. That's it. Don't let go, please.
Don't let that wire touch your wristband.
Yeah.
You feel it?
Yeah, sure can.
Who else wants to hold it?
I believe it. I don't have to hold it.
So you get it around there. That might be a little better.
Remember, you've got a scare device on your hand. It might stop it.
Feel it?
Yep.
Who else wants it? Everybody else done it? Anybody else want to try it? I'm going to reverse it now. I'll let you feel the opposite direction. This is a simple way of, and you can do this during the operation of the wheels, all four wheels. And all you have to do is touch one button and these things are released because the momentum of the wheel carries them around.
That's right.
Instant reverse. Now, you see the planets have reversed the pattern of the planet orbit. Who wants to go it first? Experience the opposite direction. Go ahead. Come on, grab it. Now remember you felt it going that way before. What are you experiencing now? Opposite direction?
Sure.
Which way are these turning on?
Right now, your force is being imposed in that direction. You see, there's a kinetic. Now what happens here is this arc here is causing it to come back. Now a very short time, this impact occurs, causing it to go forward. Now you have a long period of time to allow this arc to occur, and that's the arc you're feeling right now. But by having the second module in place, you will no longer feel this one. All you'll feel would be this one pulling it forward with the four-wheel module. That's the force that's pushing it that way.
Your force actually comes from killing your
Momentum of the mass.
your momentum sideways and
At an angle.
using your accelerative force to push it the other way when you're going.
Thank you. How simple can it be?
Yeah, it's beautiful.
Now, they say the simplest things are the best. Now, when you see a simple little one, if you're just looking at one wheel, that looks pretty very simple to me. Now, if I've had it with two planets on, forget trying to understand what's happening, because all you're having is like this all over the place. I have got a tape here. I could show you a small segment in animation with the two on each wheel. It'll drive you out of your mind. Slowly. But if you watch only one planet, you'll see it doing what it's supposed to be doing, eh?
Yeah.
But then you're seeing this. Woo, oh, it's just crazy. It's just driving you nuts. But she works. I leave that to your judgment. Does it work or does it not work, gentlemen?
Can you roll it up the table?
I don't think it'll work too well on the table.
Sure.
That is not doing what it's like.
Keep it going, I got a good video of it.
That's great, that's fabulous.
Well, it's certainly better than the
It's better than holding it. It's more visible.
That's the second generation device.
Gravity device. He says after 3 years of trying to generate Canadian support for his propulsion machine, he's going across the border. Roy Thornson says he can't get anyone from the federal or provincial governments to even look at his invention. Yet the United States has approved a patent for the device.
When we submit our funding prior to August the 15th or 14th of this year, the patent will be issued to us, and the patent will be in force for 17 years.
Thornson's invention, called the Ezekiel Propulsion System, has been endorsed by Dr. Ronald Rice, the Chief of Transportation Systems at Expo 86, as being a revolutionary form of propulsion. It uses the reactionary forces of gravity and just a small amount of gas or electricity to power it. Thornson is working on a larger prototype of this basement model now, but he still hasn't found any local financial backers.
So it looks like we'll either be raising funding privately, an associate is going down east to try to raise private capital, and if that fails, I just hope the Canadian people don't look with disdain upon me if I happen to end up in another country developing this.
Thornson says getting the American patent is an important step.
It means also that we are genuine, that the force does exist, and the surprise that I've encountered is the lack of interest when you start to think of all the jobs it could create here right in our own province.
$1 million would be a shoestring budget for Thornson. He says he needs at least $3 million to produce a propelled boat or glider using the Ezekiel system. He claims production of his device could create 1,000 jobs in Manitoba in 2 years.
What I'd like to offer within 18 months with proper funding would be a device that could put into the space shuttle itself and give the space shuttle total propulsion within a zero-gravity vacuum so that they could leave their orbit, do their investigation out of orbit, come back, return to orbit, and then return to Earth.
Thornson says the United States and another country he refuses to name have shown interest in financing the first stage of his invention. He's confident it will be put to use somewhere, but his loyalty to Canada is wearing thin after continually being ignored here.
This is the first prototype that we were speaking about. Heavy vibration was experienced between 0 to 750 revolutions per minute. Surpassing these revolutions, vibrations ceased to smooth operation, and it continued to do so as the wheel accelerated up to its maximum 3,000 revolutions per minute. As a single wheel is only one half of the module, it attempts to oscillate around its center of mass in motion. It was observed that when one side of the wheel carrier was firmly fixed to a concrete floor, the opposite end of the stand experienced a substantial weight loss. When reversing the procedure to the other side of the carrier, the same sustained weight loss occurred. The RPMs range from 30 to 60 to demonstrate experimentally the controlled positive and continuous propulsion force being exerted in two directions. Reversing the centered controlling gears reverses the direction of thrust. You'll notice that it is pulsating from 0 to approximately 2 on the scale at this moment. I will now reverse the center gears. The center gears are now reversed, and the indicator dial, or indicator rod, when it went in the opposite direction, went to the positive side. It will now go to the negative side, as illustrated in this demonstration. The force...
Edison and his light bulb. Examples of inventors with ingenious ideas that changed the world. I think we all have that romantic vision of the eccentric inventor seeking to defy the laws of nature and succeeding. Well, that dream is not dead. It's alive and well in a basement in St. James. Here's John Drabble with the story.
This is the latest contribution to Backyard Inventions. It's called the EZKL, the Energy Zoned Kinetic Lift. Its inventor is Roy Thornson, a middle-aged real estate salesman who lives in St. James. Thornson has some astounding claims for his device.
I would venture to say that a person, if we all got into my car in the driveway, if it was equipped for this, we could lift off the driveway up for half a mile up or a quarter mile up, and probably be in New York City within around 45 minutes, and possibly with a consumption of about 3, 4, 5 gallons of gasoline.
It may sound like science fiction, but his invention has attracted a lot of local media attention, as well as the interest of a number of scientists and engineers.
Well, the most significant visit, I suppose, is by a man by the name of Bill Horvath, who is an aerospace education specialist with NASA. Mr. A.J. Pankratz from AGP Engineering Services has given us a wonderful letter of endorsement. Fred Kuhn, who is a engineer with Bristol Aerospace, is behind us 100%.
Thornson takes his idea very seriously indeed. Even before he lets you see the machine, he makes you sign a form that legally bars you from telling anyone how it works.
Oh, no, you sign over here. You sign over here, and I'll just initial.
Okay. Roy Thornson is what you would call a basement inventor. He hasn't any formal training, either in physics or engineering, but he does have drive. He's earned dozens of real estate sales awards, including top salesman for the Permanent in 1979. He says he's been working on his device for the past 11 years, but in the last 12 months, it's become something of an obsession.
It is strictly a new form of propulsion, differing in principle than any other forms of propulsion presently being used.
Thornson managed to construct a rough model of his device, but he's very careful to keep the actual operation of his machine a secret. He'll show it to you if you sign the forms, but the only way he'd let us film the machine in action was to conceal the working parts. Thornson says this is only a rough model, and as such isn't very spectacular. The machine does move forward in the pan of water, albeit very slowly.
You have a 3-foot rope, and I attach a 10-pound weight on the other end of the rope and throw it out. It's going to pull you forward. Well, what my device does is as it's thrown out, it pulls you forward, but then the device pulls itself towards the mast at that same instant.
Thornson is convinced his machine will revolutionize transportation. This is his idea of what will replace the car in 20 years. It will lift off the ground like a flying saucer and move in any direction. But Thornson has never been tested. Thornson's convinced it works.
As a matter of fact, every engineer first coming to my home walks in a skeptic, and every engineer who has walked out of my home walks out with a new understanding.
But does it work? One of the engineers who has seen Thornson's machine is Gordon Saunders from the National Research Council. Saunders calls the EZKL a form of reactionless drive.
As far as I know, that's contrary to nature. It means that it's contrary to the laws of Newton as we know them. Reactionless drive, well, there isn't one as far as I know. Everything that we know and understand has to have action and reaction, like a rocket or a car driving, engine pushes on the ground or something like this.
What's your feeling about it? Do you think it would work if it was measured?
Right now, the way I understand it, no, I don't think it would work.
Why is that?
Because I don't think there's any such thing as a reactionless drive. You never say it never can happen, because we've seen things happen that you don't think are going to happen. And you don't know why they happen, so that's why it should say, take it and test it. If it does do this, something we don't understand, let's understand it. And then we put some money behind it.
The days are long gone when someone like Alexander Graham Bell could invent the telephone virtually by himself. Most discoveries these days are made by teams of PhDs working in vast laboratories. But that doesn't stop people like Roy Thornson from plugging away in their basements, looking for the next great Canadian invention. And who knows, someday they might succeed and put all the skeptics to shame. For 24 hours, I'm John Drabble.
I'd like to introduce is that when I look at that huge document prepared by Leonard Holohan's group in London for inertial propulsion concepts, I began to realize that the work of Branson Roy Thornson is sort of like a quantum leap in inertial systems. And there seems to be no precedence to the thinking. I could find only one fuzzy relationship, now that we know, at least I know how it works, one fuzzy mention of a thought by an Italian colleague of mine. I used to, if you do not know, I studied in Polytechnic of Milan, and there was one of my previous professors in physics, mechanical engineering, I should say, had come up with an idea that was remotely similar to this, but this is still a much more advanced system. Unfortunately, the quiet and non-agitated device is not operational, but in a sense it does not do what it's supposed to do yet. And I think that's the problem of alignment. But at least you see what an improvement there is between the operating system and the one that is to be refined in a matter perhaps of weeks, I hope. So I introduce to you Branson Roy Thornson, a full-blown Canadian right from the heart of our country, from Winnipeg, Manitoba.
Good morning, and thank you very much. It was very kind of Andrew to invite me. I've had a lot of good moral support. I'm going to try to speak from a paper because I'm limited in time, so if you'll bear with me. As I say, my name is Branson Roy Thornson. I started this, I first conceived the idea in 1973. I started working seriously by building a metal wheel, in 1981-82, just to see if this out-of-balance wheel would fly apart like shrapnel. And much to my surprise, it didn't. So I continued on, and I made a little plastic model, two-wheel system, which actually causes a form of vibration. But then I can bias the vibratory force and produce a resultant force in one direction by utilizing the centripetal forces caused by vibration. And then by going on a little bit further, well, if I may start, if you'll excuse me, I'll try to read as quickly as I can. The energy zone kinetic leverage propulsion system is referred to as the next generation because its principles differ entirely from all presently used propulsion systems applied to transportation. All propulsion force systems develop a force to be imposed with friction against an external medium to cause a reaction that translates as a propulsion force or thrust. The only propulsion systems that we are familiar with are those which we use and see every day because they're the only ones that are manufactured, such as cars, trucks, trains, and planes. This is the only form of system that we have available at present because the perspective of the engineered design of all systems is focused upon the accepted concept that a medium must be present to produce a propulsion force by way of reaction. The reason this perspective is focused upon mediums is basically founded upon the acceptance that Sir Isaac Newton's laws of motion must be applied verbatim and interpreted as such, and is interpreted that a medium is absolutely necessary. The EZKL system's principles do not violate any of these laws of motion in physics. Rather, this new propulsion force relies upon the dependability of the second half of Newton's first law of motion. Quote, unless it is compelled to change that state by forces impressed upon it, which subjects the rigidity of all these laws to conditional change. The concept of converting rotary motion into linear motion, producing thrust, with no reaction is not a new idea, but it is assumed to be impossible as it appears to violate certain laws in physics. And it's pursued up until now deemed to be foolhardy. The EZKL converts rotary motion into linear motion, producing thrust with no apparent external reaction. Internally manipulated masses cause vibratory centripetal forces to be imposed upon each wheel's axles in a controlled manner. This centripetal force is the same force that causes that very powerful action called the vibration, which is usually looked upon as a negative and destructive element because of its strength. A single wheel is out of balance. That's the EZKL wheel. And if it rotated, simply oscillates around its center of mass or balance. The first step is to convert this oscillating motion into linear motion confined in two directions. And by joining two wheels to a common plane with their axles parallel and causing the wheels to be turned symmetrically opposite, all of these centripetal forces are regimented to impose these forces in 4 equal directions. The forces imposed in the direction along the common plane allows no movement along that direction, as they are neutralized by equal and opposite forces produced from within each opposing wheel. But the forces imposed perpendicular to that plane, or that common plane, or the line XX as I refer to it from axle to axle, are imposed in an alternating manner and causes the common plane to vibrate. A bias of the perpendicular centripetal forces imposed is caused and produces a continuous resultant force being imposed in a single direction that affects the whole of the mass of the system and causes the mass of the system to be propelled and affecting any mass to which it is attached. My best friend, who is also my wife, gave me her permission to develop this contraption and said, "How can a dream come true if you haven't got a dream?" And all of us are experiencing that yesterday's science fiction is becoming today's science. Because the learned ones have taught us that which can be imagined in the mind is capable of becoming reality. So, starting at the beginning and imagining a 6-ounce mass attached to a 2.5-inch arm, which is fixed to an axle which is being turned at 1,000 revolutions per minute, we would observe that a 6-ounce mass is attempting to pull the axle in that direction toward the mass, and this is caused by centrifuge. We determine the strength of that centripetal force imposed upon the axle by first determining the mass velocity in feet per second. I use very simple formulas, and I'm a very simple, unlearned person. And I think Is that right? Okay.
Here's an
Thank you very much.
You can lift it on with
Okay.
otherwise.
Well, I might hand it. This is going to follow me up a wee bit. Okay. Let's try it this way here. Take it over on this side here. Am I in the way? Probably. I'm in everybody's way. Okay, the formula that we use for calculating the velocity is fairly simple. V is equal to 2 pi r times 1,000 divided by 60. And this results in this radius becoming 2.5 over 12. And that relates at 1,000 RPM that it's 21.8166 feet per second. Then the centripetal force in pounds, I use the formula FC equals 1/2 of the mass in pounds times its velocity in feet per second squared divided by 2. This would result, if that was a 6-ounce weight, or mass, that the pounds imposed pulling, like if you were turning it with your fingers, it would be imposing a force of 44 roughly 44.6 pounds. In other words, your hand is being pulled towards that mass with that strength, which is referred to as a centripetal force, which we're all familiar with. Examining one EZKL wheel and its components, we see internally mounted a 1¼ inch pitch diameter sun gear. Now, this would be, if this were the wheel, I don't think I made that very big, did I? Oh yeah, okay, we'll call that a planetary gear. Here's a sun gear, and here is another planetary gear. There is an axle, and looking at it from the side, as you can see here with this little model, this little sun gear is fixed by a rod extended through the axle of the wheel itself and held stationary. As the wheel is rotated, this planetary gear, when it comes down to here, has made one full revolution. Upon making one full revolution of the wheel, this has to make 2 revolutions to return to this position. So if we attach a crankshaft throw at that position, I'm going to lose my place in these notes, I know it. Crankshaft throw located at the center of the line of mesh of each planetary gear causes the throw to continuously alter its distance from the center of the wheel's location. When it leaves here, it forms its own orbit and goes into a state of acceleration until it comes up to here, where it is at peak acceleration. Then, on its return back to the point of the heart, it decelerates to a complete stop position at that point. Okay, attaching a free-swinging pendulum-shaped planet to this crankshaft throw causes that the centrifugal force imposed upon that planet causes the planet to be extended away from the axle of the planetary gear at all times, because the planetary gear is being rotated at double the RPM of the wheel itself. So therefore, when it's over here, when this gear is here, the crankshaft throw is here, and the planet is extended like so. When it comes down here, it makes this little arc in here. That's where the gear is here. The planet is extending straight down like this. Okay. God, this is difficult. I hope you'll bear with me. So this is now producing a different form of orbit. Comes like this, loops over the center, and comes back out here. Now, when we attach that free-swinging planet, pendulum-shaped planet mass to each wheel throw, each throw, which centers on its mass, is equidistant to the center of the planetary gear axle, and causes the wheel to be turned, allow the planet mass to describe a concentric orbit path with a continuously changing degree of curve, and causes the planet to describe a loop over the center of the wheel's axle, causing the wheel to be out of balance and oscillating around its center of mass. Relative to the center of the wheel's axle, which will be referred to as a common plane, it is observed that the velocity of the planet is continuously accelerating and peaking at the furthest distance from the wheel's axle, which position is referred to as the major arc peak, and produces the greatest centripetal force upon the axle of the wheel. Upon passing the peak position of the major arc, the planet velocity continuously deaccelerates to the axle center until the crankshaft throw arrives at the point of the inverted heart shape, right here, and the velocity of the throw ceases just momentarily as the planet describes the minor arc over the center of the wheel axle and produces the lowest centripetal force imposed upon the axle in the same direction as the major arc. Passing this point, of course, the throw begins to velocity to return to the acceleration phase of the planet orbit and begins to increase the centripetal force strength that is imposed upon the axle. Determining the velocity of the planet mass at that moment its position is at the peak of the major arc is accomplished in 2 steps. First of all, if we have this orbit like this, we see we have one 1¼ inch gear here, another 1¼ inch gear here, and then from the center of this, you can't see it? Oh, okay. Maybe I should do start over for this silly thing. If you have the wheel here, and there is the center of the sun gear, here's the center of the planetary gear, and this is the center of the mass, we see that we have 1¼ inches and 1¼ inches, which is 2½ inches. If we place an imaginary spot on the wheel as the wheel is being rotated, this is the center of the wheel here, we find that we have the first, I call this the first major velocity, is equal to 2 pi r, which is 2.5 divided by 12 times 1,000 divided by 60 equals 21.8, oh gosh, 21.8166 feet. Get rid of that quickly. The evidence is destroyed and Andrew won't hit me too hard. Now, the strange part is the planetary gear is revolving or rotating at double the RPM of the wheel. So that planet is being carried past the spot at a velocity equal to the velocity of the spot itself. So therefore, the planet velocity at that point, at the peak of the major arc, is actually 43 feet per second. When the planet comes to the peak of the minor arc, in other words, returning back to this point here, we look at the planet, there's the crankshaft throw, here is the center of the mass, which is the center of the axle of the wheel itself, and this is the center of the axle of the planetary gear. We know that the wheel is turning like this around that center, but because the throw has come to a dead stop, that has now become the radius point from the center of the crankshaft throw to the center of the planet itself, the planet mass. So therefore we say that that radius of that circle, if it were a described circle, would be 0.625 inches. And because the planetary gear axle is being rotated at 1,000 RPM, I formulate that the velocity of the planet would be rotated around in a circle with a 0.625 inch radius, and it equates as this is the first velocity minor arc. I got ahead of myself like a twit. I'm really following this up nicely. What we do determine, we have two different velocities. The velocity here is 2 pi times 0.625 divided by 12 times 1,000 divided by 60 equates to 5.45 feet per second. So therefore we see that the velocity of the planet passing over the center of the axle is considerably different than the velocity of the planet describing the major arc at the same moment in time in the same direction. So if you calculate the centripetal force produced by a 6-ounce mass traveling with a velocity of 43 feet per second, it equates to 178 pounds is being produced by this planet mass, and at the same moment in time, because this velocity is reduced down to 5.45 feet per second, we equate pounds. We equate the minor arc as producing 2.788 pounds at the same moment in time. But because as these two planets are imposing this same force in the same direction at the same moment in time with two planets mounted in each wheel, we can say that there is an aggregated force of 180 pounds imposed in that direction at the same moment in time. Now, we have to now look at if you have this major arc and that minor arc in two wheels, can you see that? You can almost see that there. That's on this side of the line XX, or the common plane. When the wheel is rotated 90 degrees, it causes those two planets. This large planet comes down and describes one arc here. This planet comes down and describes an arc here. This planet is coming in the opposite direction, like so, and this planet is coming in the opposite direction, like so. And we find that the radius of each one of these arcs are identical because the center of the axle of the planetary gear align themselves along the common plane. One is in a state of acceleration and the other is in a state of deceleration in both wheels. But their velocities at that moment in time are all identical. So according to the laws of Newton, we can see that as these are the only two forces imposed in the opposite direction, opposing the 180 pounds imposed in the opposing direction, we automatically say that, well, if this and this is worth 180 pounds, well, this has got to be worth 90 pounds, and this has got to be exerting 90 pounds, this has got to be exerting 90 pounds, and so does that. So this adds up to 360 pounds being exerted in that direction upon the plane, and then alternatively we have another 180 here and 180 here, 360 pounds exerted upon the plane in that direction. I hope that makes sense to you. It does to me a lot. I don't know, I'm sure. If you don't follow this, please ask questions later on. Okay, when we add two other wheels, I'm going to ignore this. When we add two other wheels to the first two set of wheels, you've got the general idea of these arcs and the path that the planet makes as it's describing its planet orbit. If we add a second set of wheels to the first set of wheels, we adjust the center gear so that all major arcs and all four wheels are imposed in this direction. Now, we lock in the first set of wheels with the major arc and the minor arc being produced producing the centripetal force in one direction. But we take the second set of wheels and turn them 90 degrees out of phase to the first set, so that the second set of wheels are producing the four equal arcs. When we turn the machine on, I have a tape I can show you where the machine operates. We had the machine operating at 900 RPM, the prototype that we're completing now. And we experienced no vibration whatsoever from the wheel as all forces were set in balance. Now, located right at the center of the axle of the wheel, each of the four wheels, are the poles of a very powerful magnet. As the planet, as you know, the planet alternate as they pass over the center of the axle location, but only as the axle is describing the planet is describing the minor arc. As the planet describes the minor arc, the magnetic field, when it is activated, grabs hold of the planet mass itself, and the momentum, like its velocity, ceases. And its momentum is converted into kinetic energy, which is transferred to the wheel itself, the mass of the wheel. But its direction is along the common plane. And the same event is occurring in the opposing wheel. Therefore, you have a neutralization of that kinetic energy transformation along the common plane. One neutralizes the other. Now, we continue to impress the force upon the magnetic field force upon the planet as that wheel with the captured planet continues to rotate another 90 degrees. When it has reached 90 degrees, a turn, that means that both planetary gears have are in their equal arc position, where one planet has described the equal arc and produced the force. The other planet, because it is held back, is not allowed to describe that equal arc. Now, as the wheel continues to turn, at that moment in time, the planet is released from the magnetic field, and its acceleration starts to increase phenomenally through like a whip-like action as the planetary gear is turning at double the RPM of the wheel itself, and it causes the planet to extend itself in the proper position as if it were going towards the opposing wheel. And at that moment in time, that force for the major arc has just been reinstated. So you have like a continuous force being imposed as you're imposing 180 pounds, the wheel is being pulled back by 180 pounds by two little equal arcs which have been produced. The other four arcs with two majors and two minors are opposing that force at the same moment in time with 360 pounds in the opposing direction, and causes a resultant force to be produced and imposed upon the common plane, causing the machine to be propelled forward in one direction. The force is continuous. The strength of the force is dependent entirely upon the size of the mass, the pitch diameter of the gears used, and the velocity that the mass is subjected to by the RPM of each of the wheels. The system itself, because the system is producing a continuously imposed resultant centripetal force in one direction, which translates as a propulsion force, you have a characteristic which rears its head, which is called continuous acceleration, which a lot of us are finding very exciting right now. We anticipate let's see, not this weekend past, but the weekend before, we took one of the wheels apart on the big prototype, and we put two Lexon plastic discs in to replace two aluminum discs which hide the planet activity inside the wheel. We had to look at the behavior of the planet because we were not getting the effect of a resultant force being produced. Now, you have an awful lot of activity going on in there all at the same time. It's very hard to see. Even when the Betamax is, you're using a strobe and watching the Betamax, you can hardly make it out until I put the Betamax onto slow motion and transfer that to VHS. That's when we found we were holding the planet in the planet trap too long. We should have only held it for a 90-degree turn of the wheel. We found out that we were holding it for a 135-degree turn of the wheel, and hence, instead of allowing the force to be reinstated, pulling the wheels forward, it was coming out too far, and the force was directed again along the common plane. When I get it back to Winnipeg, we anticipate it will take 1 day to take the wheels apart. It's very complicated because there was over 750 pieces in that box, that wooden box that never existed before. The magnets inside, I guarantee that nobody has ever seen magnets like that ever structured that hold and produce that much shear strength. I'm quite amazed that we happened upon it. I'm quite amazed that we made it work. We've developed, we started off by getting 1.5 pounds of shear strength, utilizing 10 amps of electrical power at 12 volts. And by the time we finished with this little rascal, with 1 amp going in and be about 3 or 4 volts, we were getting 18 pounds of shear strength with 5 amps going in, we were accomplishing 28 pounds of shear strength, and at 10 amps, we were getting 38 pounds of shear strength, and the machine has a capability of taking 15 amps, so we're anticipating we could have a shear force strength of approximately 50 pounds, which of course would allow us to bring the wheels up to probably way beyond 2,000 RPM. This machine here has been designed to operate up to 1,500 revolutions per minute, and when we are successful in having the machine function properly, we have calculated the force strength that would be produced at 1,000 revolutions per minute. The force strength will be equivalent to approximately 407 pounds of thrust will be imposed at 1,000 RPM. That'll be 4,000 pulses per minute. In other words, the box will want to go forward. It'll pull you forward with a force of 400 pounds, and it will impose that force of 400 pounds 4,000 times per minute, or I think that equates to approximately 66 times a second. And at 1,500 RPM, the force goes up to around 570 some odd pounds. I can't find my little paper here, my graph that everybody's worked out for me. It goes up to 578 pounds of thrust, and that thrust of 578 pounds is imposed 6,000 times per minute, or 120 times a second. The patents have been issued by both the Canadian Patent Office and the United States Patent Office. They're here for you to view if you'd like to have a look at them. Our patents are pending in the United Kingdom since 1983. All the annuities have been kept up to date. The European patents are in good standing, and they're still pending. And our Japanese patent is standing. All the annuities have been paid up to date, and they're just sitting there waiting to be exercised, I would guess you would call it. I have a little demonstration model. As I said, you're free to have a look at that, and if there's anybody here later wants to have a look at the VHS that I've brought to show the machine pulsing across the water, is filmed by CBC in Winnipeg, and CKND TV and CKY TV. We showed various experiments where that machine, the plastic machine, is put on a styrofoam float, and it propels itself across a tray of water. Another experiment was where we attached the machine to a little piano, very stiff piano wire, and on a scale, it's set at 0 on a scale from 0 to 10, minus 0 to 10 positive, and we show the machine pushing against the little bar where it doesn't go back and forth over 0. It stays on one side of 0, goes to about 4, and then when we reverse the thrust, it goes in the opposite direction to 4 and does not go over 0, just continuously pulls it in one direction. And I think I'm from Missouri. When I hear something as ludicrous as what I'm telling you, I got to be shown I'm from Missouri. So that's why I brought the little plastic model. If there are anyone with any doubts, please, you're welcome to come up. I'll place it in your hands. You hold it yourself. We will turn the wheels at roughly 60 revolutions per minute, and let your brain, which is a greater computer than any computer in existence on the face of the earth, make your decisions for you. I think that's about all I have to say. If there are any questions, feel free to come forward. Oh.
Is your videotape very long? Maybe you could show it to us right now?
You wouldn't want to see the whole thing. It lasts over 2 hours, but I could show you excerpts.
That'd be great.
Yeah. Okay, all right. What's on? Yes, it is. And this tape was oh, something's not right here. There. Mr. Warren Andrews filmed this tape. He came in from Toronto. He's quite adept at filming, and he embarrassed me a little bit. When you hear this, you'll... I had to let you see and hear this. One of the life's embarrassing moments. You getting a kick out of this, Ed? I'll go. I'll search forward because it's too long. It's not been edited. Like this, the first part was done rather well. He edited it rather well, and he sent me a copy of the tape, and then I added on to the back end of the tape the progress of the machine as it was being developed, all the parts and the pieces, and I can show that to you briefly if you're interested in it. I'll just try and get through this as quickly as possible. It's been quite an ordeal. Mr. Ed Orton, who's in attendance today, he was at McMaster and he saw the machine working there for the first time. It must be a little bit boring for you right now, Ed. But it seems to be getting more interesting as time goes on. It seems that more people are beginning to understand how the machine works, and it seems that people who have the right expertise have, for some reason, come to me. The machine you're looking at on the table has been built by the man who's building the astronaut's chair for the National Research Council in Canada. Oh, God. Here we are again. Where am I? Here we are. He was asked to build the astronaut's chair that they're using for the National Research Council tests for their free-fall flights for the new Canadian astronauts who will be subjected to zero-gravity environments in this big Boeing 707, I think it is. And I've had so many people come to me. An airline pilot, Mr. Barry Broad. He's an amateur electronics specialist. He's an electronics genius. With some of the timing mechanisms he's prepared, they're back in Winnipeg for the machine when we use it. It just seems that all the right people seem to be coming together slowly but surely. And I would suggest that when we get the machine back in Winnipeg, I would say that we may have the machine, we probably will have the machine working probably within, I'd say, 1 to 3 weeks. And we hope to take that box, a big wooden box, and put it in the back seat of a two-place tandem glider owned by Robert Deemert, the fellow who owns the Carmen Airport. He wants to be the first one up because it will produce, we're operating it at 1,000 RPM. It'll produce about 410 pounds of thrust, I think it's 66 times a second. And that is about 25 pounds more pull than a Cessna 180 engine, with a prop fully tethered, if you hold on to the tail end of the airplane while he's trying to pull forward. He gets 370 pounds of pull. This box will probably pull the glider up with a greater force of over 400 pounds. Oh, come on, Roy. So this basically explains the same thing as I just explained to you. I don't know, maybe I'm getting a little battle-worn explaining this to everybody continuously. I hope I haven't bored you today. But this gives you a rough idea, like sort of an animated show of what's happening inside the wheels, roughly. Just by watching it slow motion, it's more or less self-explanatory, I find. Except when you start looking at the garbage work. That's where the planet is trapped in the bottom wheel, and it's just being trapped in the upper two wheels.